Good morning. This lesson is from our Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll title it how I title it in the title. But what I am sure of are 3 goals for the day. Our first goal is going to be introduction to the natural log and the common log. Our second goal is going to be graphing a logarithmic function. And our third goal is going to be finding nice points for more complicated functions. Let's go ahead and jump right into our first goal. So, introduction to the natural log and the common log. So if I have this function which translates to y equals log base b of x, we're going to be focusing today on 2 special bases. This number. And the way that I write my logarithmic function tells me which number I have. Okay? So again, like I said, we have 2 special bases for logarithmic functions. The first is e. Remember, e is a number that's created from a pattern using exponents. And it's important to logs because logs are inverse functions to exponential functions. And so this number e is important. And you'll see in calculus next year why else it's important. All right, so an example with e as a base. So we would say y equals log base e of x because e is a base. Because e is a base, we don't write it like this. We write it like this. And this translates to y equals ln of x. Or we could say y equals the natural log of x. So whenever you see this, you know that you have e as your base. Okay, so this is the natural log. Right? So if I have y equals ln of x, or y equals the natural log of x, I know that I have base e. Okay, so I'm telling you that. All right, the second special base is 10. Powers of 10 are interesting to us, right? So here's an example with 10 as a base. Y equals log base 10 of x. Because 10 is a base, we rewrite it as y equals log of x. Notice there's no base. When there's no base written there, it's implied that the base is 10. So we could say y equals log of x or y equals a common log of x. But most people just say log of x. This is called the common log. So if you have no base, it implies you have a base of 10. Again, if you have natural log of x, it implies your base is e. Okay. So, I'm going to repeat myself again. Y equals ln of x implies e is the base, and y equals log of x implies 10 is the base. I repeat myself a lot. All right, so let me go ahead and check off the first goal here. And let's get into an example of graphing a logarithmic function. So let me clean all this up and I'll be back. I'm back. So let's go ahead and start our second goal, and that's graphing a logarithmic function. All right, let's review what the order pairs mean for a logarithmic function. So if I have y equals log base 2 of x, let's just make sure we understand what it is. The x value is what 2 to a power equals. The y value is the exponent needed. So if we choose x to be 8, and we chose that because 2 to the power 3 is 8, that means that y is 3. So remember, we get to choose the value of x, but choose it so it's a power or a multiple of that number. And that way we're guaranteed to find nice outputs, nice y's, right? So because we chose x to be 8, that means that we need the exponent of 3 to get to 8, and we get the ordered pair 8, 3. Not 2, 8, 3. There we go. All right, and 8, 3 is a point on the function. I like to use 7 points to graph. I will list the powers of 2 to find ordered pairs for y equals log base 2 of x. So if you have a base 2, write down the powers of 2 and put the power to the 0 as your middle value. Do that, and it'll make it easier for you. So, 2 to the 1 is 2, 2 to the second is 4, 2 to the third is 8. And when you go in the negative exponent direction, you're just flipping them because, remember, negative exponents flip numbers, right? And so, again, the middle one, exponent is 0, and then we have the pattern as it goes. So from this, I can write 7 ordered pairs very quickly. So my x here is an 8th. And I need an exponent of -3 to get there. Here, my x is a 4th. And I need an exponent of -2 to get there. Here, my x value is 1/2. And I need an exponent of -1 to get there. Here, my x value is 1. And I need an exponent or y value of 0 to get there. Here, my x value is 2. I need an exponent of 1 to get there. Here, my x value is 4. And I need an exponent of 2 to get there. And here, my x value is 8. And I need an exponent of 3 to get there. All right. Real easy to find ordered pairs on these things, right? So let's go ahead and graph these. I'll start with this one. 8, 3. 8, 3. Okay. Right there. Okay, 8, 3. 4, 2. 2, 1. 1, 0. So slide over just a little bit. 1, 0. And now we get into the negative one. I'm sorry, not negative 1. 1/2 for the x. So I'm halfway between, but that takes me down to -1. Right? And then a 4th is halfway between the half, right? So that takes me to here. And then an 1/8 at -3, so I'm getting a little bit closer. And if I was to connect my dots, and I'll connect them in a different color so it's very clear what's happening, we get the following graph. All right, and again, we want to know where the behavior changes, because that's an important place to pay attention to. So this is where the behavior changes. And again, the behavior is based on the sign of the exponent. Right? That's the border where it changes. So you see that when the exponent is positive, we get a very flat graph. When the exponent becomes negative, we get a very steep vertical graph. And what's happening is the more negative the exponent gets, the smaller the number, so the closer we get to the y-axis. You know, if we keep multiplying and multiplying, even though it's a negative exponent, remember we're multiplying a positive number by itself over and over and over again. So we get closer to the y value, or the y-axis, as the value of our exponent increases in the negative direction. And notice we'll flatten out. The next point would be 16, 4. So we would have the next nice point way out here, right? And the graph becomes nice and flat. But this would be an example of a logarithmic function as a graph. So you will be asked to do this on your homework, graph a couple of functions by hand. And again, just list the powers and you got it. So let me check off that second goal here. Let me clean all this up, come back with the third goal, and I'll be back. I'm back for the last time, I promise. So we're on to our third goal, and it's finding nice points for more complicated functions. I guess maybe instead of nice, it should have been how to find easy points, right? Easy to find points for complicated functions. Anyways, too late now. I've already done the first two sections, and I'm not recording this again. Okay, so our third goal, find a nice point for a complicated log function. That's what we want to do. Remember, we get to pick the number we plug in. So we can write it in whatever form we want. We can write our numbers in such a way that they untie things for us. They make them simpler for us. And this lesson that we're doing today is based on a lesson we did way back at the beginning of the school year. So hopefully this seems a little bit familiar. All right, so we want to write it so it cancels out the complicated part. We get to pick how this number looks, right? So all the examples that I'm doing have base 2. So it will be helpful to write out the powers of 2. See, they all have base 2. So I'm just going to write out all the powers of 2. And I'm doing that because on your guys' assignment, you're going to be asked to find, I don't know, 5 ordered pairs for each function. And so the first thing I would do if I were you is I would write out the powers of the base. And, you know, have the 0 power in there because that's kind of an easy one. But anyways, let's go ahead and move forward with this. And hopefully as I work through this, you're reminded of one of our beginning lessons. So we want to think a couple moves ahead and make these more complicated problems look easy. So why don't you think for a second what you could plug into this guy. So for example, we're going to have a target. We want to get this. We want to constantly get to here. That's our target, right? And so on the homework, you're going to want to hit the other targets, but I'll show you how to hit that guy. Okay, that's our goal to hit that. So hopefully you hit pause and you figured out what I have to plug in so I can get to leftover with 8. All right, so here's what I'm going to do. I'm going to let x equal, and I'm going to get a better marker, excuse me. I'm going to let x equal 8 minus 5. And I chose that minus 5 because it's going to cancel out the plus 5. I could have put it together, but I don't want to do that. I just want to write it so I want to be left with an 8, and I want to make you go away, so I'll just say 8 minus 5. So now we have y equals log base 2 of my x value is 8 minus 5, and I'm going to add 5. Well, minus 5 plus 5, guess what? You cancel. And so now I'm left with y equals log base 2 of 8. Well, I know what exponent I need 2 to have, so it becomes an 8. I need a 3. So that means that y has to equal 3. So I know what x equals. X equals 8 minus 5. And y equals 3. Now, I can actually simplify that one. That was the one I can simplify. 8 minus 5 is 3. So I can find a nice order pair by plugging in 3. All right. Example 2. Y equals log base 2 of 3x. Why don't you hit pause and think about what you can plug in as x, so we're left with an 8. What could you plug in? So hopefully you take a second to think about that and try that. Hopefully you did. Anyways, if you did, I'm back. All right, here's what I'm going to let x equal. I'm going to let x equal 8 over 3. And I wrote it as 8 over 3 because the 3's are going to cancel out, right? So now we get y equals log base 2 of 3 times 8 over 3. Well, guess what happens here? You cancel. So now I'm left with y equals log base 2 of 8. Again, my exponent, which is y, needs to be a 3, so I get to 8. So my ordered pair that I found with a not so nice logarithmic function is going to be 8 over 3, comma, 3. There you go. I got stuck there for a second. I was trying to think and nothing was happening. All right, on to the last example. Literally the last example. So why don't you hit pause and see if you can figure out what to plug in. I had to film this again because I made a mistake. So I know what I'm going to plug in. So hopefully you hit pause and you tried it. And here's what I'm going to plug in. I'm going to let x equal, let's see here. I want to be left with an 8. I need to cancel out the 5. But I also need to get rid of that 3. This is what I'm going to plug in. Okay, this is what I'm going to plug in. Now it's a much more complicated version of the number that you could actually plug in, but I guarantee the ones in your homework won't be this nice. Anyways, so let's plug that in. So now we get y equals log base 2 of 3 times 8 minus 5 over 3 plus 5. All right, so let's see here. What cancels? Well, the 3's cancel out. Boom, boom. And now I'm left with y equals log base 2 of 8 minus 5 plus 5. Well, guess who cancels next? The 5's. And so now we're left with y equals log base 2 of 8. Well, that means that y has to be 3. So now I can write my ordered pair, which is 8 minus 5 over 3, comma 3. Now, by the way, 8 minus 5 is 3, 3 over 3 is 1, or 1, comma 3. But for your homework, they won't work out to be this nice. You're going to have to get some complicated looking fraction. So hopefully I've explained how to easily find ordered pairs for more complicated logarithmic functions, and it's a lesson that we've seen before. So this was the last example for the whole school year. This is the last lesson for 2021. Again, this has been a very interesting year. I'm thrilled that we've made it to the end. I'm so happy that we made it to the end. This has been a tough year for me. I can only imagine how tough it's been for you guys. I hope that you guys finish strong. I wish you all well in the future. I hope everyone's doing all right out there. Have a great day, everybody. Bye-bye. Thanks for playing along. Good luck. Oh, by the way, these videos will always be here, so if you ever get stuck in the future, hopefully you know how to navigate them and find what you need to help yourself out or recommend it to a friend. It doesn't matter. Take care. Goodbye. Thank you very much.